Alright, so today we're going to be talking about Ocean-Continental Convergent Boundaries. So I have this helpful map here, and this is pretty complicated, but what we're mainly going to be talking about today are these two, the convergent point boundaries here, right? So, let me just zoom out of this map a bit. Over on this left side here, I'm just going to go up here and make this circle tool so you can see it. Oops. Ignore this top two. Or three, or however many, right? So just focus on this one here. What you're going to want to do is just fill this. Oops. Did not mean to do that. So we're done with the fill tool. So this little model here is a terrible representation of the Earth. Right, so just think that's the Earth, right? And the ocean-continental boundaries are where, as the name implies, an ocean here, ocean combines with a continent, and they are tectonic plates, of course. So you essentially think you have two tectonic plates, and they are colliding together. So when these collide, they can cause many things. I'm just gonna type them up here. So they can cause volcanoes, earthquakes, and more. Right. Volcanoes, earthquakes, and more. So we're going to talk about that a little bit more a bit later, but the idea of this is just to get familiarized with what a tectonic plate is, which you already know, and convergent plate boundaries. So, yeah. Right, so what I told you earlier was kind of generalized with most of the types of tectonic plates, but I have a more helpful diagram. So let me just put it in. XCK12. Alright. So once we've done that, this. Okay, there we go. So this is a much more accurate diagram here. So basically you have the oceanic crust, as I said earlier, and the continental crust, which means that this here is a continent and that's an ocean. So continent here, and ocean would be open, right? Now that is assumed, but so what actually happens here is, so what happens is basically you have the two plates here, as you can see, and what happens is one of these plates here, and the other one subducts into the other one, which means that as it collides in, it's sort of, see, you can see this one is coming down, and this one is sort of, this, the left one here is sort of combining into this one, and it's called subduction, and that can make, well, I had brought up earlier that it can make volcanoes and earthquakes, but it can also make deep trenches in the ocean. It's very exciting, and there's also the volcano there, which I had talked about earlier. But yeah, so they're the two plates, and they are subducting. I'll actually put that in here. Subduction as a term. That was way too small. try that again, man. Right. Subduction. So that is what this overall process is called, and that is what's happening. Next, we are going to be talking about the 2 to 3 largest ones in the world. Hello again. Today we're going to be talking about the 2 to 3 largest ocean-continental convergent boundaries in the world. So earlier I had talked to you about subduction, and we're going to talk about 2 or 3 places where that is happening the most. So first one over here, we have the... Sorry, let me just type this in. We have the Juan de Fuca plate subduction, and then over here we have the... I don't know why my font size got so small. Probably isn't coming up over there, but... Alright, so we're going to start over on the left here with the Juan de Fuca plate subduction. So the Juan de Fuca plate is a very small plate. This is up in Washington, as you can see, and essentially what's happening is the continental crust is larger than the oceanic crust, and the Juan de Fuca plate is the oceanic crust, and it is being subducted with the North American plate. So this Juan de Fuca plate will be subducted sometime in the future. And also here, you have the North American plate, and they are subducting. Again, it looks pretty complicated, but it really isn't when you look at it. But what's happening is this is creating a trench here, this Cascadia Trench, and it's also creating this Juan de Fuca Ridge. It's a ridge under the ocean. So yeah. Then this next one over here is the Nazca plate subduction. So the Nazca plate is a very, very small plate compared to the rest of them. It's still really big, but it's colliding with the South American plate down here, as you can see here, right? So right around here, it's subducting, and this blue bit here is the what's it called? The ridge, and the trench is down here and up there, and it's all being created with this plate subduction in mind. Not in mind, but with the plate subduction, right? So yeah, I think it's pretty interesting what happens with these